Hello everyone, myself Ashish Desai, Assistant Professor, Mechanical Department. Today we are going to discuss here the unit number 2, manufacturing. So in that content we are going to discuss the part programming. So first of all we look at the learning objective for this session. So first learning objective is to understand the part programming. Then second learning objective is to know the fundamental elements for developing manual programming. So after this session some learning outcome is there. So first learning outcome is the student will able to explain about the part programming. Second learning outcome is the student will aware about manual programming. So this is regarding the learning outcomes. So first of all, we look at the texture for the drawing to the workpiece. So how it deals. So first of all, we know that the detail drawing. So if you have a component, so we have to know all these things regarding the that component, that tolerances, limit, fits. So as per this uh, reading of this drawing, we move for the part programming, that is programming method. So we have to generate the toolpath. So for that purpose we have to use that preparatory and miscellaneous code, that is nothing but G code and M code, and we have to use that programming methods as per our requirement. Suppose NC programming is there, then second is computer programming is there. So there are two methods. One is a NC programming and second is a computer aided programming. So this is second method. Then third is the part for inputting the program. So after completion of this program we have to feed into the machine, and then we have to formalize the finished product with the help of machines. So the machines will be NC or CNC. So this is our the tool path follows. So this is the flow chart from reading drawing to the manufacturing. Now we will concentrate first the part programming. So actually the part programming is a sequence of instructions that can be describe the work which can done on a part which is formed required by a computer under the control of NC, or you can say it's the task of preparing a program sheet from drawing sheet, and all the data is fed to the numerical control system using a standardized format. So that standardized format is nothing but NC part programming. So it requires the machining data for that purpose, as we know that the sequencing classification of process. So if you know that all the machining processes, then you identify the tool starter point, then cutting depth, tool path, etc. So this is regarding the first machining data collection. Then cutting conditions, spindle speed, feed rate, coolant, etc. So this is regarding the second machining data. The third is selection of cutting tools. So as per your requirement, we can select this tool. So to suppose example, the drilling machine is, drilling operation is there. You can select the drill bits. If you select a facing, then you can, according to your usage, you can take a face mill or other type of mill. So this is regarding the machine data while preparing the that part programming. Now we move for the steps regarding the part programming. So first step is the study of component drawing. So as already mentioned, so in that content we have to extract the dimensional data from the drawings. So here we have to collect data from the part drawings, and regarding the surface quality requirements on the machine, we have to study over here. Then next we have to move for identify the machine tool. So after selection of the tools and determining the tool offsets, we move for the setting the zero position for the workpiece. Then next move for the tool selection. So here we know that tool motions, so it is dependent upon the profiles. So there are two tool motions available with us. So first one is a continuous tool path and another is a discrete tool path. So in continuous tool path, it is if example is countering. Counter means you have to remove the material outside of this object. So that time it is called as continuous tool path. And discrete tool path means suppose two diameter size of hole is there. So you have complete first diameter, and after that you can go for second diameter drill bit. So you have to change the tool two times. So that is nothing but discrete tool path. Means what? So here you have to change the tool. So this is regarding the selection of cutting tools. Then we know that the selection of machining parameters. So here speed and that feed rate is there. So speed is in terms of that rotation, that means RPM, and that feed rate, so it is in terms of per minute. So we can mention this. So this is regarding the machining parameter. Then prepare the jobs and tool setup plans. So tool setup means we have to define the WCS system, that is work coordinate system, and according to we have to select the machine. So here we have to select first that cutting tools geometries, and after that we can go for writing the part program. And after writing this part programming, we move for the test part program. So before that, when you are returning the cutting tool, we are giving the reference point. So that distance we have to move in a rapid traverse, and after that we can test the parts. If it is not okay, then we can go for again determine the machining parameters, and if it is okay, then we go for MCU, that is machine control unit, and according to that it should be perform the that tool path, and finished product will be finalized. So this is regarding the documents for the program, and here we can inspect the part also. So this is nothing but steps involved in a part programming. Now we move for the next point, that is fundamental elements for developing part program. So already mentioned that the part programming consisting with NC oblique CNC machines. NC means numerical control and CNC means computer aided numerical control. So these are two types actually, the part program. So first is a manual part programming. So we can with the help of writing we can generate the part program, and here second part is computer aided part programming. So in that case, computer will generate the program for the CNC machines. So in order to that part programming, the programmer decides the machine parameters, as well as it can choices the machine tools and cutting tools. So depending upon the machine's operations. Then here we have selected the coordinate systems. Then we have to select the sequencing, and then we have to state the details of operation. So this is regarding the part program. So again I repeat, there are two types of part programming is there. One is a manual part programming, and second is a computer aided part programming, that is CNC. So in manual part programming only we have to write this program according to the operations, as well as according to the knowledge of the machine tools and cutting tools. So then we go for finalizing the that manual programming. In computer programming only we have to select the tools, then work coordinate systems, then uh, tool rate, feed rate, and then finalize the component. So this is regarding the computer aided manufacturing, or you can say computer aided part programming. So here only you have to select the tool, feed rate, tool rate, so spindle rate. So this type of selection only required in a computer aided part programming. So this is regarding the fundamental for part program. So in accordance with, as we know that we have to know the all manufacturing processes, then also known to the sequencing operations. Suppose example we take face mill first, and then we go for the component on drilling purpose. So this is nothing but a sequencing of operations. So as per your experience, we can select the operation sequence. The next, according to knowledge of selection of cutting parameters. So here we can decide the feed rate. It is in terms of per minute, or you can say spindle rate, or in that we can say that RPM, that is revolution per minute. Then next we have decided here editing the part program according to the design changes. Suppose if you change it in a that tool, or you can say if you change in the workpiece, so according to that we can change easily. So this is advantageous point. Then next, knowledge about the codes and functions used in part programs. So in that session, we are focusing on this codes used in the functions for the part program. So first of all, we look at the manual part programming. So in that, programmer can that prepare a manuscript for standard format, that is about in terms of G code and encode, and it should be manuscripted in a flexible writer. And if it is complex shape is there, then this method is difficult. That is about manual part programming, and this point is suitable for point-to-point machining. So this is nothing but that manual part programming. Again, I repeat. So here we can prepare the program manuscripts standard format in terms of in a flexo writer, and if it is complex shape is there, so it is difficult to that calculates the part. So this is a major disadvantage of this manual part program. And if you prepare the simple machine parts produced on the point-to-point machine tool, so this is regarding the manual part programming. Now we move for second part, that is computer aided part programming. So in that case, the complex shape is can uh, easily produced with the help of programming softwares. So nowadays the programming software is available with us, that is Delcam, then Fusion Cam. So according to our usage or according to your availability, we can select this, and complex shapes geometry, that is continuous toolpath is there. So that time you can use this type of machines. So here the various programming languages available with us, that is APT, that is automatically programmed rules, then adapt, then autosport, then compact second, then 2CL, Romance, then Spilt. This is software used for the computer program and which has the English statements. So this is the change for that computer aided part programming. So here we can require the compiler program which is used to translate it in a acceptable MCU, that is memory control unit. Now we focuses on the axis and motion nomenclature. So here the finger is there, so that hand finger that that finger is denoted y-axis, x-axis, and z-axis. So always remember that this is positive axis. So if it is horizontal is there, then positive, and if you towards our side, that is z plus, and above the side, that is plus y. So according to that, we can formalize the machine coordinate system. So in that case, these are the positive moments. So this is positive, and opposite of that we can consider the negative moment. So this is called as the machine coordinate system. Now we move for the next thing, that is the axis motion nomenclature for rotary motions. So here the right hand rule for the determine the correct axis on a CNC machine. So it can be determined in a clockwise direction, that is x, y, and z. So to determine the positive or clockwise direction about an axis, close your hand with thumb pointing about. So this is regarding the rotary motion. So in x, y, z direction for thumb, it should be curl for the fingers. So it should be represent a clockwise and anti-clockwise directions, or you can say positive rotation in about the axis. And these are known as ABC, that is called as rotary motions, and it can represent in a programming, and it's about x, y, and z coordinate systems. So this is regarding the rotary motions. Now we move for the structure of NC program. So this is the block we are constructing for any program. N is a block number, G is the proprietary code, so that is called as G. Then X, Y, Z, that is called as coordinate system. Then F is a spindle feet, then it is in terms of per minute. The next miscellaneous function. So here the program start, program stop, or can say that spindle start, spindle stop. So this type of operations will be there. So it is considered in a miscellaneous functions. Now we move for the spindle speed. So spindle speed is in of RPM. Suppose yes 1000 we can mention here. So I can easily identify that is 1000 is RPM. Then T. So this is tool number. So if your jobs, so 01 is the first tool, 02 is second tool. So according to your requirements, the tool will be there. Then last block is a EOB. So at the time end EOB is there, that is end of block. So this is the sequencing of the or can say structure of the NC part program. Now in connection with this N001 that represents the sequence of operation, G01 that is called as preparatory function. So this is regarding the linear interpolation. The next x 1 2 3 4 5, so that should be positive directions along with the x-axis, and about y 0 6 7 8 9, so this is regarding the table move in a y-axis. So this is regarding the fundamental elements. Next M03, that's we are indicating a miscellaneous form, so this should be clockwise or anti-clockwise. So this is the scenario for structure. So always remember that at the left hand side the sequencing number, then preparatory function, then the dimension against the x-axis, dimension against the y-axis, and last is a miscellaneous function. So it should be miscellaneous function is spindle clockwise, anti-clockwise, or you can say uh, spindle start, tool change. Like this operations will be in the miscellaneous format. Then next we move for the detailing of program code. So that N code indicates for the number of block number. So if it is 5 or 10, allow the additional blocks to be inserted if in future. That means N5 and N10 is there. Suppose here, according to the N code means that is number of each block. Suppose this is N5, this is first block, and if you required in a future we require changes, so we can add 1 2 3 4 above the side, 1 2 3 4 we can add it above the side, or can say we can select 6 7 8 9. So this is regarding the CNC program. So here again I mentioned the G code is called as preparatory code, then the M code is called as miscellaneous function, and it can involve the necessary for machining, because M code is nothing but spindle on off and colon on off. So here G is indicated that preparatory functions, as we know that. Then M code, so here M code is there, so M03. So according to that we can write the operation. Now we move for the next, that is called as program code. That program code G code is there, that's why it is called as preparatory code. So this is the uh, chart here. G00 that is called as rapid traverse, G01 that is called as linear interpolation, G02 circular interpolation. Third plane is nothing but circular interpolation CCW. Then fourth block number is the, we can say that G04 dwell is there, G08 acceleration is there, G09 declaration there, G17 that is XY plane is there, G18 that is ZX plane. Then next G20 inch in units, G21 metric units. So this is regarding the letter codes about the G code. The next for G code is G40, that is cutter compensation cancel, G41 cutter compensation left, G42 that is cutter compensation right, G70 is the ribbon inch of format. Then next is G71 that is metric format, G75 or 4 full circle programming off, then full circle programming on for G75, G80 for fixed cycle, fixed scan cycle, G81 to 89 that is fixed cycle, then G90 absolute dimensions, B is the G91 that is incremental dimensions. So this is called as preparatory codes. Now we move for the absolute versus incremental positioning. So while defining the first one, that is absolute positioning, so this is current position, and if you define for next tool position, so how you can write it as a x40. So here 0 to 40, because not only we can take 20, we have take the reference value, so that's why I can write x40, and y about 50. So y about 50. So already I mentioned with the absolute positioning. So x is a 40. So here we are considering from reference point, that is from origin. So that's why I can take this point to this point. Is it clear? This is absolute programming. That is x40 y50. That is x40 and y50. x40 y50. And for incremental positioning, only we have to defining for x20 and y30. So this is regarding the incremental positioning. Only we have to mention about current tool position to next tool position. But in case of absolute programming, what will happen? You have to defining from origin only. So this is a simplest method for obtaining the part programming. So first is the absolute positioning and second is the incremental positioning. Now we move for the that miscellaneous code. So already we discussed the preparatory code. So miscellaneous code is nothing but M00, that is program stop, M01, that is also optional or can say operational program stop, M02, then program end, M03 spindle on clockwise, M04 spindle on counterclockwise, M05 that is spindle stop, M06 tool change, M08 coolant on, M09 coolant off, M10 is that champs or can say clamps on, then M11 is equal to clamps off, M30 is equal to program stop reset to restart. So this is regarding the M codes. Now we move for the program code, that is miscellaneous functions. So already mentioned that miscellaneous function is nothing but program start, program stop. And before that, we have to discuss here the preparatory code, that is that more direction or can say coordinate system, that is X. So X, Y, Z, that is coordinate system. So here at the end of move related to one incremental or reference value, then the number may require that a specific format is used at 3.4. Now we move for the program code. So in that case, the letter codes in the I, J and K codes, if you require the center of circle, so while defining this code, we can go for I, J, K. The next number following on the code defines the coordinate system and the end of the move related to an incremental or absolute reference point. So mostly here we have to observe the absolute reference point. So only changes that we can consider from the dimensions from that 0 position. The next, the number may be required that a specific format to be used. 3.4 means 3 number before the decimal and 4 decimal the that 3 numbers before the decimal and 4 numbers after the decimal. So this is nothing but 3.4. So here the N5, N10, N15, N20, N25, N30. So this block is called as sequence of operations. And why we enter the 5 to 10? Because in a future, if you required in between that, we can insert the lines. So according to that, we can insert these lines. So here this is regarding the IJK. So here we can define the center of circle. Then next for the program code. So F code. So apart from the G code and M code, there are different codes there. F code. F code is available with us. So this F code indicate that feed rate. So this is feed rate. F10 is called as a feed rate, and S code. S code is called as spindle speed. Okay, spindle speed. And T code is for associated with the tool change. So according to the subsequent operations, we can change the number of tools, that is called as T code. Now we move for the part programming, how it is blocking we can write in the producing the parts. So this block already I mentioned, this is sequence number, then this indicate the interpolation, that is if it is linear interpolation or circular interpolations. According to that we can change it over here. Then x 0.50 and y 2.5. So this is called as x coordinate and y coordinate. And for feed rate we can write 15, that is meter or can say mm per minute. So this is about the part program. This is block system. Now we know that this blocking system with the help of the sequencing operations. Now we can take exercise for that. So this is the N001. So here mention that 2 times 0, 1. That is called as a block, or you can say sequencing of operation. Then that is 0. So that is N000, 10. That N0010 indicates that number. And G90. So that what is G90? Absolute mode. So this is called as absolute mode. So always remember that G90 is absolute mode. N0010, that is called as the sequence number. Now next is the N0011 G01 X1 Y2. So here tool moves to 1 to 2. So 1 is X and Y is 2. And 0011 is called as a sequence number. So here also N0012 is the sequence number. G01 is called as the rapid traverse. X2 Y2, that's why the tool moves to the point 2, that is X2 and Y2. Now next point is the next exercise for the program is G then 0013. So this is the next program sequence. Then G91, that is called as incremental code, or can say incremental mode. G91 is there, that's why I can take incremental mode. Now regarding the X0 Y0 Z0, so this is the value is for the reset the 0. So here we can say that reset 0 is there. Now next is the same, that is X0 Y0. So here also if you mention that G00, so this is the rapid position is there. Now we move for the next part, that is computer aided part programming. So here CAD CAM interface is there. So we have to first draw the jobs in a CAD, and then we have to interface with CAM, that is computer aided manufacturing. So in that case we have to produce a geometry with the different dimensions. Then next we move for, after the scanning of geometric files, we submit it to the tool positions, or can say tool motions. So here sequencing operation is there, then machining parameter is there. So in machining parameter, as we know that the number of code is there, that machining parameters, that is feed rate for F, then S is for spindle rate, T for tool position, or can say tool number. So this is regarding the machine parameters. So as per your requirement, we can change these parameters, and if it is given to the processing units, so that post processing will be done. So this is NC program. So here we can do the job according to our requirement. So here we are requiring the specific operations, then defining the repetition of work, defining the work part geometry. This is regarding the computer aided programming. In next lecture, this is about the CNC part programming. In next lecture, we have to move for detailing of this part program, part second. Thank you.